Hi, welcome to this session on artificial analysis, voice text analysis capabilities by SaaS providers. So that's a quite a mouthful. Essentially, what we are going to do in this discussion is introduce you to the very fundamentals of artificial intelligence, and then look at what are the various SaaS providers giving us. That this is organizations like Amazon or Google or Microsoft, and then we'll specifically focus on voice and text analysis, more around text analysis, to provide what is out there, what is available, how you can probably incorporate these into your product. So let's get into the agenda. So basically, we're going to start with a quick introduction about ourselves, our organization, what we do. Then we'll very quickly touch over artificial intelligence, deep learning, neural networks, so on and so forth. This is like very quick. We'll just look at them and run. We'll then get into what are the various SaaS offerings and capabilities available today. So this is where we discuss what is out of the box, what can you tweak, what you cannot tweak, those kinds of things. And then we will look in detail around transcription, translation, and text analysis offerings that are there, and then go with certain recommendations that we think are out there today. So what we will not do is get into details about neural networks or deep learning, or we will not discuss what is an RNN or a CNN. Our focus would be on practical applications of available technology as a lowest common denominator. So we are saying, okay, I'm not trying to design a compiler here, or as an analogy, I'm not trying to design a compiler or something like that, but I'm going to just use what is available to me. And then we are going to focus around business capabilities and not as much as scientific capabilities of these things. So you'll benefit most if you are someone who is looking at incorporating AI, specifically text analysis and translation and transcription, into your existing products without trying to develop these capabilities internally yourselves. You're someone who's probably consumer of a technology and not an inventor of a technology. So with that, let's just start. तो यार यहाँ पे मैं मतलब बता दूँ, पहले दफ़ा डिस्कस कर लेते हैं कि हम करने क्या वाले हैं. So let's start with the basic definition of what is an artificial intelligence. Now this is one of the classic diagram in textbooks like Russell Norvig, which describes what AI is. It basically says that an artificial intelligence is a machine that can act rationally in response to its environment. Now this is a fairly broad description and can mean anything. It can be something like a chess playing agent, where the state is the current state of the chessboard. Its sensors are maybe a camera which sees what is the move, and then its response can be done with maybe a mechanical hand that moves the pieces. Its environment is obviously the chessboard, and then it can also be changed. So its objective is to win the game, so it can probably have a reward based system. Now this is a perfectly valid definition of what probably an artificial intelligence system is, but it is not very useful to us. So we're going to look at a definition that we want to use today. But before I get into that, there has been also quite a bit of philosophical debate about what AI is, and two specific thought experiments that were given in favor and against it, which were around can machines be intelligent, the Turing test and the Chinese test. Now the Turing test says that if you ask a question and you get a valid response and you cannot tell if that, and so it's basically saying that there's a dumb terminal over there, and then you ask a question onto it and then someone responds to it, but some of the responses may come from a machine and others may come from a human being, and if you cannot distinguish between machine and human being, then the system is intelligent. And in fact there are contests around this that happen On the other hand, the Chinese test basically says that let's assume that there is a human being who has a lookup a book or a table or whatever you want to call it, which basically if you give him a sentence in English, he has a mechanism of looking it up and giving you a translation back and vice versa. But the individual does not have any understanding of Chinese, so does he really know Chinese? So basically they're trying to say, can you really build an intelligent system? So let's get into our second definition of artificial intelligence, which I think is more applicable in this discussion. Artificial intelligence is a mechanism by which computers will solve problems without explicitly programmed to do so. So we all have some understanding of computer programming. Computers follow step-by-step instructions, and they basically only do with the work within the parameters of these instructions. However, artificial intelligence is a mechanism in which you program a computer so that it is able to learn, and you don't explicitly inform it how to solve a particular step. So, for example, when I'm making it learn about theorems which can be proved, or a mechanism in which I'm showing it images of elephants and lions, and it is able to detect elephant and lion, I'm not giving explicit steps to what is an elephant and what is a lion. So it has that capability or ability to learn from it. That's what they are talking about, and this is a definition that we will probably will keep coming back to. Now, artificial intelligence can be realized by various techniques. Initial ones were explicit programming, which was obviously not a part of the definition we said, but they had little success, and then they started developing rule-based systems. Prolog was a excellent language to do this. Basically, it had a number of facts and then some axioms or rules, and using that you could prove or disprove theorems. You could basically approach it from a perspective that, given certain facts and rules, is this valid or not. This technique was used in developing systems like Mycin, which were early attempts towards artificial intelligence. This system could basically, based on symptoms and other information, predict what disease an individual had. How today our focus will be on machine learning and deep learning, more on deep learning. So let's start with that. So what is machine learning? And I think everyone has some idea of machine learning. Machine learning is an approach towards artificial intelligence where the algorithm tries to detect statistical patterns in data, and that's why when you go into a machine learning algorithm, you are explicitly saying, hey, here is my data, and probably I want to cluster it into sets, or maybe I want to build a linear regression. So in machine learning, you know something about the data, but probably is its use case or structure, and then you use AI to build it. For example, a good example of clustering that we developed for one of our customers was in the area of automated marketing. Now, what we did was that the customer had, over a period of time, acquired a lot of data, and it was realized based on a number of variables like age, demographics, education level, job profile, tier 1, tier 2, tier 3 city, and a number of other variables, that different individuals react to a different kind of marketing strategy. And so So we had, I think, 25 or 30 variables, something of that sort, and we did this on AWS. And essentially what we did was that we learned that what was successful and what was not successful for a subset of these individuals. And basically what we did next was that we built a clustering algorithm, and based on the said demographics we were able to cluster our individuals and define what exactly the marketing strategy would work for them. So this is nothing but detecting statistical patterns in data, where we put them in buckets, and we were able to essentially very clearly focus on how to approach them from marketing. Should it be a Facebook ad? Should someone call them personally? Should someone meet them? This email? Do they need education about the product? So on and so forth. So scores of marketing strategies could be very quickly tried and perfected. So again, let's look into and we are very quickly coming to the end of these formal definitions, and after which we'll look at what is available. So let's look at deep learning. So deep learning is a type of machine learning. So we already said that we are looking at a statistical mechanism towards mapping inputs and outputs, which uses artificial neural networks. Again, we'll look into what they are in an upcoming slide with multiple hidden layers. Again, we'll look into that. Here is what is important: that creates a hierarchical representation of data in order to make predictions on data. So what does this mean? What it means is that if I was to recognize a face, what is the ability or what is the hierarchy I need? I need to first be able to detect simple geometric shapes like lines and circles and ovals and so on and so forth. Then use them in a next layer to probably understand and build on these geometric concepts to understand the concept of an eye and a nose and a ear and so forth. And if all of them were available at their proper places, then say this is a face, and probably have more details like male, female, so on and so forth. So this is that hierarchical representation of data, and then it makes predictions on data. It doesn't definitely say what is right. It basically uses a probability mechanism to have a high probability to map your inputs to a data. So let's go to another more easily understandable definition of deep learning, which basically is based on statistics. So deep learning is nothing but application of statistics to AI, and a neural network essentially attacks the problem of AI as if it was a regression or a curve fitting problem. And when we will be looking, so when all these inputs come in and you have to have an output, what it is trying to build is a function fx, which is a numerical approximation of probably what should be an ideal face detection procedure or function, and it's trying to approximate it as a n variable, n dimension order, whatever you want to call it, kind of a mathematical equation or a procedure, which when fed in these inputs can tell you whether it is a face or not. And within deep learning, both input and output can be images, video, text, voice, tabulated data. So some examples could be image captioning. You give it an image and it captions it and tells you what that image is about. On the other hand, you could probably have a deep neural network where I could ask it to paint a new flower for me. Now, see the potential of this. Currently, we have to spend a lot of money on designers to get that exact thing right through multiple iterations. But if I have a neural network which works, then I can probably ask it to make those images for me. Or designers could use that as a starting point and fine tune it. Another example could be I could ask it to make, I don't know, something as simple as my picture in Rembrandt style, or more complicated things could be that my voice could be matched to that of a celebrity, and of course that can have legal implications. But that's essentially some of the examples of deep learning that are possible under research but probably not available today as commercial. So now we are coming to this diagram, which probably everyone has seen. which in my view is the single biggest reason why there's a lot of confusion about what a neural network or artificial intelligence or deep learning is. So everyone who has seen this basically goes through this, that there's an input layer, there are weights, and each single neuron gets all the inputs, and then it multiplies them by weights, and then you have an activation function which basically again brings it into 0 and 1, and then you get an output. And if the output matches, you basically back propagate and adjust the weights. I think we have all probably gone through this. The problem with this particular interpretation, though completely correct, is that it loses the focus on the large picture, which we just discussed, that we are trying to build a statistical regression function or something of that sort. Now, there are also academic problems with this model on a conceptual level, and some of them are. So, some of the problems that are described, at least by the academic world, are things like there's no predictability of result. You exactly do not know what the end result will be and why it is like that. So you're not able to experiment with, say, a single neuron and then build on that. The second thing is that a lot of researchers claim that this is not really a model of the brain. We don't, first of all, we don't understand how the brain works, so this is not an accurate example of that. Brain works at few hertz, this works at many megahertz. And then the last problem is when if this were a model of the brain, then when even a small child can look at a single picture of an elephant and then learn about it, whereas you need scores of data to be able to, thousands of images before a neural network starts recognizing. On a practical level, something that is probably more concerning to individuals like us who are trying to train data, and specifically with chatbots this happened, that because that's a place where you have to train it, you end up doing a lot of overtraining, which is basically the weights and everything saturate to a point that if you give it more new data, fresh data, is not able to learn more. So with this large understanding of what at a theoretical base of what artificial intelligence is, let's focus now more on the capabilities and SaaS offerings. So major players like Microsoft, Google, Amazon are now providing SaaS offerings towards some of the more common problems of artificial intelligence and deep learning. They are providing automated transcription where whatever I'm, say, for example, speaking gets written into a text. In fact, all the notes that I prepared were done in this manner. What I had done was I had recorded an example of doing this, and then I had just put it into a transcription, and then I got results. Automated translation is another area where a lot of work is being done. I believe that, if I'm not mistaken, at this stage Skype is trying to do something of that sort, where two individuals with different languages will be able to communicate. There is also voice generation. In fact, in various accents, Amazon Polly is a really good example of this. Text analysis is something that we're going to be talking about quite a bit in this discussion, where we talk about things like sentiment analysis, keyword, and so on and so forth. Image classification and tagging of images is another one. You can figure out what is the image. Is it a man, woman, child, age, so on and so forth. Car. Video analysis, similar to image analysis, is available. In fact, a lot of people show that off. And then finally, conversational AI using chatbots, where using the concept of entity and intent, your question is mapped into an intent, which basically what is it that you're talking about, and then entity, what are the specific entities you're trying to talk about. For example, if I might say, show me sales for customer X, then my intent would be show sales, and probably my entity would be customer 1, and then I can have a backend engine processing this as a query, select star from whatever, and something of that sort. So these are the SaaS offerings from a perspective of features. Let's look at them from a capability point of view. So pretty much all engines are giving SaaS platforms in these three models. The first one is out of box, where they have a set of APIs, and these are fully ready to use. So they have probably already figured out some of the most common use cases. I don't know, something like translation. So they have probably figured out translation engines, and you can use them. These are easy to use, no customization available. And what is good about this is that it is an out of box. Probably the smartest AI professionals have developed this, trained this. So it's like these have a success capable aspect or ability much more than what we could train, develop, and design, unless we obviously put in the resources. The second one is, on these APIs you could train them with your custom data. So let's look at an example. I have face detection capabilities, and I have celebrity detection capabilities. So everyone knows who the celebrities are. So I have the ability to look at a picture and map it to a specific person, and this is available. Now I could have a business problem where I want to integrate into some sort of advanced biometric, where as soon as my employee walks in, by looking at his face, the camera should be able to mark them as present or absent. Now this has the benefit that I have a model available, a neural network available, which is trained on a slower level, so it can detect a face, it can all know, so on and so forth. And all I need to do is train it with my specific data set for my employees. Now this mechanism has limited customization capabilities, but it is very, very easy to train. So for most people, the out of box capabilities and then training the model within your custom data is probably where you would want to play. There of course is Keras or TensorFlow, as most of you would be aware, are the libraries on which a lot of functionality of AI is built. So they are available as software as a service offering as well, where you can build your own neural network, train it, and host it. So it's pretty much this one is, if I might draw an analogy, this is like having MS Office Online, whereas this is ability to maybe change some macros or maybe have some kind of imagery, while this is exactly like having an EC2 cloud where you are building everything from scratch. So let's get into the various services that we want to talk about today, which is transcription, translation, and text analysis offerings that are available from Google and AWS. So we did some work with Microsoft, Google, and AWS, and we found at the point of our POCs that capabilities provided by Google and AWS were something that we were more interested in. So that is the reason why we are looking at it. So I'm just going to, and a lot of this now I'm going to talk about is probably things that we have experienced and our learnings. So first is transcription. Transcription is the ability to take a voice and in a given accent and then record the text. So both Google and AWS are fairly matched on this. They can both provide speech to text, both for recorded files and streaming files. They both allow custom vocabulary and speaker diarization, which is basically saying that if you have 5 speakers talking at the same time, then who's who. And speaker diarization is in beta, and at least when I had done the POC, even the transcription service was in alpha. So I don't know at the stage of it's where it is. However, AWS claims to be production ready. Translation is one where Google supports around 104 languages which can be paired. It has certain exceptions, whereas AWS has 32. What I learned when I was working with both these platforms was that translation kind of loses the message to a certain extent. We did some work for automated analysis of speech or text that was coming in, and some of it was in Hindi. So we had following issues. One was that in India nobody uses purely Hindi or English or one language. There's this mix of Hindi and English together, so it was not as efficient in detecting those. Abusive language was categorically, at the time we did our POC, was dropped off, and we had to train it for abusive language. And but essentially what I saw was that the impact or the meaning when I read the text, whereas heard the voice, that was kind of missing in these. And then at this stage I believe AWS actually got something where they can listen to the voice and at the same time predict sentiment. So that, in my, at least during the POC time, was not available, and it just did not have that impact of what I would have if I would have learned from the original. So essentially what I'm trying to say is that if your transcription is into a language which can be then analyzed directly, you're probably better off than a translation. So sentiment analysis, Google provides a score between -1 and 1, -1 being a negative and 1 being a positive with strength, whereas AWS provides a score for positive, negative, mixed or neutral, and then it says which one has 1. While AWS is easier to use over here, I believe that with a little effort, Google's analysis can be more productive. In key phrases, AWS was able to detect good key phrases again, but what we learned that content classification that is provided by Google is a much more applicable and capable tool, where they have up to 700 classifications of content. So basically what is it that you're talking about is there. Now AWS has a similar thing called topic modeling, and the reason we did not put that in detail is because it requires training to start with, so it's not something that you can use out of box. Finally, we learned about entity detection. Now this is where both Google and AWS provided entities, but they kind of placed importance on different entities. So this is one area where AWS would probably miss something and Google would miss something else. But this is where you need to learn from your business what is important. Again, these can be trained, and Google's content classification can be trained. Now, at the time of creation of this document, AWS has also come up with something called medical comprehend, where they are working with terms that are more in the area of medicine. So if that's something that interests you, you should probably look at. Now if you look at any provider's business or marketing campaign, they will probably show you something like this: translate to a native language, transcribe, then you translate, then you do some sort of text analysis and report. And as easy as it sounds and looks, this doesn't work. At least in our experience, it is not exactly there. So let's just look at some of the problems that you could encounter, specifically if you are not an English speaking native. During transcription, within our experience, we have learned that the accents, even of like Hindi spoken by a Hindi speaker, just do not are just not there. So there are certain problems at times it's just not able to figure out. A good example that you probably would have seen is if you have Alexa or Google at home, then when you are asking them to dial a certain number or find a certain song, it may or may not get. But when we worked the same with English speaking users and found that the transcription quality was much better. As I had said, that translation before kind of loses its impact when done from one language to other, and that then affects everything downstream around analysis and everything. So if you have a native English speaking application which then which does not require translation, this flow is probably good for you. On the other hand, if you are an individual whose use case will require translation, you will face certain challenges and you'll probably have to train the model to a place where it works for you. So finally, I want to talk about what my experience has been with enterprise customers and B2C users. So we did some work for enterprise customers, and this is like almost early this year, early last year, early 2019, and our opinion on the enterprise side was that this is probably not ready for enterprise, these technologies. And the reasons for that is that the error rate is still high, but that doesn't mean you should abandon it. In fact, if you go to our Startup Glide website, there is an article written by me which specifically talks about the next generation user experiences, user interface being purely conversational. Whereas when we did it for B2C customers, relatively higher error rate was acceptable. The another thing that you need to think about is licensing and privacy around choice of platform. Amazon's license is very close to what an enterprise would need from a security and other perspective, whereas what we've learned is that Google's license is relatively liberal, as they can use the data that you collect. So in my view, as the any technology that comes has a second coming, whereas you need technology gets launched, everybody needs it, but then they finally realize they don't need it, and then there is a second coming. So there's the second coming, and enterprises need to be ready for it. So what should you do? Basically, if it's an enterprise problem or any other kind of problem, while your initial beta might roll out with data as it stands or applications as they stand, but eventually you would need a platform where your custom data and custom trainings happen. So as an enterprise, this is an opportunity for you to invest in big data. Start collecting information that you think is going to be useful. The second thing that you need to ask yourself is the problem that I'm trying to solve of my analysis or anything, is that really a deep learning problem? Because deep learning has some specific use cases, or can it be solved by more humble things like machine learning in an enterprise? Or does it not even require that, and just some basic statistics for prediction like bell curves and other things, can those do that? So I mean, a lot of this is around prediction, data analysis and everything, but the question is, is the problem that you're really looking at, is it a deep learning problem or not? Because most enterprises are probably at this stage of development and technology maturity as this exists in the world, are at a place where they want three things. So if I might just go back a little bit in history, so you had, if you all remember our software analysis and design, we used to talk about management information systems, which collected a lot of data and then provided us reports. Decision support systems, which where the reports were condensed, analyzed. That's probably one, and then expert system, which could make recommendations. The data is probably there. You also have probably reports. Now all you need is a mechanism where, using statistics and other techniques available in machine learning, you can analyze a report and actually recommend next steps, and those are based on your business experiences. So if an event happens, with whatever probability, what is probably the root cause of it? For example, if sales goes down, then probably I need to look at my call plan and my customer engagement plan. Is it correct? If it is not, then I have to make recommendations to my sales people to make calls to certain customers. So that one-to-one correlation is probably what most businesses are looking for. On the other hand, if it is really deep learning that you need and your problem needs to solve, then you need to look at whether out-of-the-box capabilities will suffice. If not, do you need to probably train an existing model? Or do you really need to build a custom neural network for a very specific problem that nobody has? Thank you.